The last functional group in this chapter are thiols. Thiols, these are organic compounds that end in SH, and these have they have offensive smell. Like, for example, the odor in onion is specifically for a compound which is propane thiol. This one is propane thiol, and this is what gives the onion its odor. Okay, there are two reactions that we are going to consider for sulfur-containing compounds: oxidation and reduction, and these are reversible. So with oxidation, we are going to start with thiols, and thiols will be oxidized into disulfides. In the general reaction, we are going to start with excess 2 moles of thiols in there. And normally thiols, we know that they end up in SH, right? So it's the hydrogen that is going to be oxidized. Remember when we were talking about oxidation, we said either you remove the hydrogen or you gain oxygens. This is the definition for oxidation. So we're going to use an oxidizing agent. Any strong oxidizing agent can do the job. And we will oxidize the thiols. The thiols will oxidize in there. In this case, they will lose the hydrogen. And since we are starting with excess thiols, we're going to end up having disulfides in there. So you're going to make a disulfide bond. This disulfide bond is the one that you are going to make. This is an R and not an H. Okay, so we are going to make a disulfide product plus, of course, water. Okay, the water is going to come from from the oxidizing agent. So the water is going to come from the oxidizing agent in addition to from the hydrogen of the thiol. So always the reaction goes as such. We will start with excess of the thiol in there, and we are going to oxidize the thiol. So each of the thiol will lose a hydrogen, and we will combine both our S's together in order to form an SS bond, which is a disulfide bond. Let's have an example on this one. For example, if we start with an ethyl sulfide, and again, we need to start with 2 molecules of this. We can go ahead and do the oxidation in there. So all what you need to do is simply remove this hydrogen and combine the 2 thiols together without the hydrogen in order to make the SS bond. Keep track of the number of carbons that you are working with, because we are not adding carbons in here. So you're going to have 3 carbons on this side together with the sulfur, and then 3 carbons on the other together with the sulfur, and that is going to be your product, plus of course your byproduct, which is going to be water. As I said, that the water is normally formed from the oxidizing agent when it reacts with the hydrogen, because the oxidizing agent is going to take the hydrogen and create the water as a byproduct. Now the thiol oxidation, so we're starting with thiols in here. It's called thiol oxidation reaction. Thiol oxidizing reaction is reversible. What does that mean? It means that I can start with a disulfide and I can retrieve back my thiol, but in this case, instead of doing oxidation, I need to do reduction. So I need to use a reducing agent instead. The general reaction is starting from the disulfide. Here you go. So you start from the disulfide and you use a reducing agent. Now, the amount of the reducing agent is always in excess. So we're going to use excess of the reducing agent. And to represent the reducing agent, always reducing agents, they have hydrogens in there. So we're going to do excess of the H in there. This is a representation of a reducing agent. An example of a reducing agent is hydrogen. So for example, I can do hydrogen in there, excess hydrogen. So what does a reducing agent do? A reducing agent simply, it's going to add hydrogens. Like oxidizing agent take hydrogens, the reducing agent adds hydrogens. So we're going to break the bond between the 2s, the disulfide. So we're going to break this bond because this is the weakest bond to be broken. And then the reducing agent will add a hydrogen to every sulfur. Okay, so my product in this case is going to be an RSH plus an RSH. So all I did is simply I added 2 hydrogens in this case, and those hydrogens, they came from the excess of the reducing agent in there. If the R's are the same, here in this case they are the same. So in this general reaction, I'm just going to combine them together and say 2RSH in there. Okay, let's have an example. We're going to have an example of symmetrical and unsymmetrical disulfide. So if I have something like this in there, I missed the sulfur. So here you go. So this is a symmetrical disulfide, and I am using excess of the reducing agent. So as we mentioned here, we are going to break the disulfide bond. We're going to add a hydrogen to the sulfur and add a hydrogen to the other sulfur. So we are going to end up getting an SH plus, this is an SH and another R. The R's are the same. Notice that the R's are the same. So I can combine those together and say 2. This is going to be an ethane thiol. You are not responsible for naming thiols, but this is what I'm going to get. On the other hand, let's say, for example, if I have an unsymmetrical disulfide, something like this, with excess reducing agent, same idea in there. The disulfide bond is going to break. I'm going to add a hydrogen here, and I'm going to add a hydrogen there. And my product in this case is going to be an SH plus, on the other side, I have my SH. I cannot combine those two because these are different thiols in there. So that is going to be my product.